special triangles, the last section of chapter 3. We're going to talk about isosceles and equilateral triangles, their special characteristics, so each one has a couple. And then we're going to use those characteristics to solve equations. Okay? So first a little vocabulary. You call the angles opposite for two equal sides on an isosceles triangle are called base angles. Okay? They're not necessarily at the bottom, they are always across from the congruent angle. So like if I had if my congruent angles looked like this, the two base angles would be here and there. Right? So they're not necessarily at the bottom, they're always across from the equal side. Okay? Does that make sense? They're called base angles, so sometimes it's easy to think of them only on the base. But sometimes if the triangle's tipped over, they're not on the bottom of the triangle. Okay? Vocabulary word, that's it. All right. Again, this theorem we kind of have talked about before. The isosceles triangle theorem says that if you have a triangle with two equal sides, which makes it isosceles, right? The angles opposite those sides are congruent. Okay? So the isosceles triangle theorem says if you've got two equal sides, which makes it isosceles, the two angles opposite those sides, which we now know are called base angles, are congruent. And the converse is also true. If these two angles are congruent, then you can say the sides are congruent. Okay? So if I said, if I told you these were both 30 degrees, is that an isosceles triangle? It says 30, I know it's not. Yes, because the converse of this theorem says if these two angles are equal, that makes the sides that are opposite them also equal. So if these two angles are equal, then it is an isosceles triangle. Okay? Make sense? Yes? Okay. That's the isosceles triangle theorem. We've done that, right? I mean, it's kind of sound familiar. All right. Then, oh, I forgot to change this again. This is supposed to say equal angular. Bugs me. Okay. The equilateral, this isn't really a theorem. This is more like a corollary, but it's what it says is, what Pioneer Pete is thinking is that if you have an equilateral triangle, meaning all sides are equal, it's also equiangular. Okay? The angles must also be equal. And the other way around. If you have an equiangular triangle, you can also say it's equilateral. Okay? So equilateral triangles are equiangular, equiangular triangles are equilateral. Okay? If it has all equal sides, it has all equal angles. If it has all equal angles, it has all equal sides. Pretty straightforward. All right? So, pretty straightforward concepts. Is there anything I can make clearer? We okay? Questions? Okay. Yes. The equilateral. This says if it has all equal sides, so if it's equilateral, it's also equiangular. It has all equal angles. So all equal sides, all equal angles, or the other way around, if all equal angles, then all equal sides. Okay? Yeah, if you were going to use it in a proof, you would just write equilateral triangles are equiangular, or equiangular triangles are equilateral. It doesn't have a name. You would just write what it is. Okay? Kind of like the theorems we did about like the two acute angles of a right triangle are complementary. That was a corollary. You don't really, it doesn't have a name. You just write that. You just write the actual corollary out. Okay? All right, so this part 2, once we learned these two characteristics, was to use them to solve equations. All right, so this is sort of like a little puzzle. If I tell you angle A is 31 degrees, see if you can figure out angle X. Take a second and do that.
That'd be 62.
Right.
Equal to 62.
Right.
And then you subtract that from 180.
Okay, why? Why subtract it from 180?
Oh, because all the triangles together equal, all the angles equal.
Right. If you add up all the angles together, you get 180. You've already used up 62, so I'm going to subtract. And that gives me 118? Okay. So this one's 118.
Because the vertical angle is 0 is equal to x.
Right. So because these two are vertical angles are congruent. So that means x must also be 118. Okay? Good job. Yes.
At 118 for the first one is could you say that it's a third angle here?
Yeah, that's kind of what we. But that's not why x is 118. But yeah. Right. Yep. Absolutely. Now let me show you. I know you guys have another year to go before the OGT, but let me show you a problem that has been on every OGT from the beginning, or every released one anyway, from the beginning of time, and that is, they give you a triangle, they tell you it's isosceles, and then they give you an angle measure up here. Okay, can you find those angles?
Yeah.
How? Walk me through it. Okay, so you know that the whole thing's 180. You used up 78, so that's 102. And then divide by 2. Why? Right. You have 102 degrees left. You know that these two angles have to be equal, so you have to split what's left evenly between the two. So that makes this 51 and this 51. Okay? Yeah. Yep.
I know a lot of people miss it too.
Yeah, you get sidetracked because you think, okay, that can be it. That's too easy. All right. How about this one? What kind of triangle is it? Well, we don't know it's equilateral. It's equiangular, but now we know that if it's equiangular, it's also equilateral. Yes. Awesome. Okay, so what does that mean about all these sides? So I can set up an equation. Someone want to give me the equation? Ella? 5 over 2x minus 5 equals 2x. You know, these two don't have a fraction. Why can't I just use those two? Why, Gabby? Okay, but they all equal each other, right? Yeah, well, what would happen if I set these two equal to each other? Yeah, we just cancel each other out, right? Is that what you could say? Yeah.
Well, I was going to say, what did that, it seems like it would work if you subtracted both ends from each side, or if there's no equation.
Right, so could you solve for x? I mean, it would work, it's true, but it wouldn't be able to solve for x, right?
But if you just put 2x plus 2x plus 2x, that is equal to 180.
Nope, because sides are never equal to 180. Only angles. Yep. Tempting always, but never. Okay, so I'm gonna change 5 over 2 to 2.5. X minus 5 equals 2x. I'm going to subtract 2x from both sides, add 5, and that gives me 1/2 x equals 5. And then how do I solve for x? Right, multiply by 2. I would avoid dividing because that seems to mess people up. So these cancel, and I get x equals 10. Okay? Now let me quickly explain this one because it's going to be on your homework. Okay. This is, what do you call that? Well, it's a height, right? and a height always makes a perpendicular. Guy, well, I guess you're on your own zero percent.